Hi, this is Jose Chavez with Risk Management Professionals. I'll be going over the PSM RMP requirement, mechanical integrity, regulation, resources, and reliability. Down below you can see my contact information, and you can always find more information on our website. Just an overview of what we'll be looking over today. I'll talk about the regulatory requirements as written out in the Code of Federal Regulations and California Code of Regulations, briefly for those of you listening in from California. Regulation will only give so much guidance, so we'll also look at the main building blocks of a good mechanical integrity program and some resources for starting one. We'll also take a look at how a functioning mechanical integrity program should be maintained, some common mistakes, and how to get the most out of the element. If you're listening in, you probably already are aware whether or not your facility is applicable to PSM RMP, but just in case, you can always go to the website below, OSHA.gov, look for the list of highly hazardous chemicals. You'll see on the bottom left the chemical name, and on the right end of that TQ, that's going to be the threshold quantity in pounds. If you're over that, then you will be applicable to PSM. Similar case with the RMP, you'll go to the website below, look for the list of regulated substances under the Risk Management Plan program, chemical name on the left, threshold quantity on the right. If you're above that, you are RMP applicable as well. For those of you in California, you can go to the link below to see if you are applicable for the CalARP RMP program. This is similar to the EPA program, just a few more requirements and lower threshold quantities. If you're still with us, you're most likely subject to PSM and or RMP Program 3. Just so I don't get repetitive from here, when I refer to RMP, this will also include the CalARP RMP. So the EPA and OSHA have developed regulations on what they want in a risk management plan or process safety management program. This good The good news is that they have nearly identical requirements. This includes the mechanical integrity program. These sections are almost word for word with few exceptions. This is a mechanical integrity presentation, but first let's take a step back at the program as a whole. You can see in the regulations and even from documentation facilities may have on site, it may seem like these are all addressed separately, each covering their own element. That isn't what the program was intended for though. If you've been in one of our presentations before, you've likely seen this wheel model, but ideally it would look something more like this. These elements should act together and be linked to pull as much information and be as productive as possible. Mechanical integrity relies on the effectiveness of other elements like providing the PSI needed for effective maintenance based on manufacturer recommendations. It relies on training to provide sufficient training to operators that'll be doing these tests, inspections, and replacements. It can rely on PHAs to find what equipment may need more attention from the MI program, and we'll see how these come into play. Starting with the most exciting part, regulations. They don't say much, but they give us our framework. All of them list applicable equipment. I'll state that there must be written procedures implemented to maintain ongoing integrity. All required training for maintenance activities. I'll list the requirements of inspections and testing. I'll require correction of deficiencies in a safe and timely manner, and have quality assurance requirements. From regulation, we see that the role of having mechanical integrity in the program is consistency and continuity. We may start with a perfect plan, but wear and tear does happen. Nothing stays perfect forever. So instead of waiting for something to fail or keeping a loose eye on our systems, we're actively challenging the integrity using a steady timeline of tests and inspections, documenting any findings, and ideally tracking any irregularities before they become issues and increase potential to cause someone harm. There are 7 parts that altogether create an MI program. This consists of creating a system for inspection on intervals using best industry practices according to API, IIAR, or the IOM manuals that come with the equipment. Program management must fall under someone's responsibility. For example, for a larger system, a maintenance supervisor can delegate tasks but be ultimately responsible. Or for a smaller system, maybe there's just one person doing management and maintenance. There just has to be someone on top of it so we don't fall into the trap of, well, whose job is it anyways? Procedures should be documented so maintenance personnel can review them when needed. The level of detail in the procedures depends on the process and complexity. These may come from the IOM manual, or they can be developed by knowledgeable maintenance personnel or a contractor familiar with the system. Training is required like any other potentially hazardous task. There should also be the minimum documentation for training, the trainer, trainee, topic, date, and how the training was done or verified, either demonstration, verbal test, or written test. The next part is inspection, repair, maintenance, or testing. The outcome of the test should be documented, and these comments can be used to change testing intervals if necessary. This is encompassed by the documentation and feedback elements. A strong MI program is possible when these 7 steps communicate with each other. If one of these parts is deficient, then the whole program suffers since they're all intertwined. Without correct training, maintenance staff might not perform tasks correctly, and the documentation and feedback will suffer. Requirements won't be changed without good feedback, and then the program won't be managed correctly. Moving on to what kind of equipment we need to include in the MI program, regulation lists the following: pressure vessels and storage tanks, piping systems, relief and vent systems and devices, emergency shutdown systems, controls including monitoring devices, sensors, alarms and interlocks, and pumps. A way to find what equipment may need some more attention from the MI program while interconnecting our RMP-PSM program as a whole is by using the PHA element, specifically using HAZOP methodology. HAZOP starts with a cause, typically a specific piece of equipment failure or a valve misposition. We look at the safety or environmental consequence of that and give it a severity level. We look at any safeguards against this consequence. The next thing is getting a likelihood, taking into account the reliability of equipment responsible for the cause, whether that's a pump, control valve system, or vessel, and the reliability of our safeguards, alarms, shutdown systems, relief devices, and so on. HAZOP is semi-quantitative with our severity and likelihood in levels, so we can put that against a risk rank matrix. And for any high-risk scenarios, we know we're going to want to make sure our equipment is under inspection. We can take that a step further by doing a layer of protection analysis, or LOPA. The goal for LOPA is to get as low a frequency as possible using our cause frequency and our IPL's probability of failure on demand. Starting with our initiating cause, here are some sample values: BPCS instrument loop failure, regulator failure, pump seal failure, and so on. Below that is the independent protection layer, IPL, which is just our safeguards, and probability of failure on demand on the right. And what we're going to do for LOPA is multiply these values, and that'll get us our likelihood that the initiating cause will happen and our safeguards will not help us. So this might give us a good idea of whether we want to include more safeguards or, in our case, increase maintenance. In addition to the PHA, API RP581 has a similar risk evaluation for pieces of equipment. It also specifies methods for determining probability of failure, consequences of failure, and inspection planning guidelines, particularly for these components. It is another good form of guidance for finding what equipment you want to put more or less resources for MI. Once you know what equipment you need to incorporate into MI and you know which are more critical, we can then bin them into categories of importance. Starting with the highest priority order, in compliance with IEC 61501, 61511, this is an international standard. This will also be broken down further into SIL 1, 2, and 3. These are based on probability of failure on demand and require a very strict, well-defined testing, inspection, and preventative maintenance. Next is high priority safety equipment. If you're pulling safeguards and IPLs from the HAZOP and LOPA, it makes sense to have any high consequence safeguards here. Also include IPLs that are the only form of protection. It may also be productive to include IPLs that mitigate multiple lower severity consequences. Not to be forgotten are low priority safety equipment. This would be applicable for other equipment failure modes that could result in a safety consequence if unmitigated, and any IPL safeguards that could mitigate a low severity consequence. Additionally, there can also be included operational safeguards in the MI program, but that is at the discretion of maintenance. The next part of MI is procedures. Regulation states that the owner, operator, or employer shall establish and implement written procedures to maintain ongoing integrity of process equipment. What this boils down to is write it down and keep your documentation consistent. This is a common mistake we find that can be easily remedied by having someone write an official procedure and having everyone else stick to it. So we need to keep everything written down, but where would we do that? Next is MI management. This figure shows a range of approaches to implementation of the MI program. Some better than others. The most effective method is using a computerized maintenance management system, or CMMS. This allows for clear scheduling of tests, inspections, and replacements. It provides communication between operators, safety, management, and other stakeholders. If you're looking for one, there's several options on the market online if you search CMMS. Now let's look at what we're plugging into that system. In terms of inspection and testing, regulation states that this must contain at minimum the date of the inspection or test, the name of the person who performed the inspection or test, the serial number or other identifier of the equipment, a description of the inspection or test performed, and the results of the inspection or test. Just a few other items we want to make sure of is that we follow recognized and generally accepted good engineering practices, and the frequency of these inspections and tests is consistent with manufacturer recommendations. If we do find any deficiencies in the equipment that are outside acceptable limits, as defined by the PSI, we have to correct those deficiencies before any further use in a safe and timely manner. Lastly, in terms of quality assurance, there are these requirements. In the construction of new plants and equipment, the owner or operator shall assure that equipment as it is fabricated is suitable for the process application for which it will be used. Appropriate checks and inspections shall be performed to assure that equipment is installed properly and consistent with design specifications and manufacturer's instructions. The owner, operator, or employer shall assure that the maintenance, materials, spare parts, and equipment are suitable for the process application for which they will be used. Now that we've gone over everything, let's pull everything back together. If you're starting out, you'll look at the requirements for mechanical integrity. You'll designate that to a specific individual for program management. That individual will create or will delegate someone to create the procedures for any inspection, testing, maintenance, or repairs. You will have training on those procedures, and after that training, you can begin any inspections, tests, maintenance, or repairs. And with that comes any documentation. And in that documentation, you can use comments from that as feedback towards improving your program. Before we finish, just one final thank you to everyone watching. We appreciate your time as well as your diligence in upholding process safety. For more information, you can contact me below or find more resources, services, and webinars at rmpcorp.com.